Hey, welcome to ITProTV. You're watching the CompTIA IT Fundamentals for exam FC0-U61. I'm your host, Ronnie Wong, and today we are coming back for a part 2 in programming concepts. We're ready to take a look at a little bit, of course, of the different languages that are out there, and Don helped us to understand more. And now he's going to show us how this works. Don, welcome back to the show. How are you doing?
I am doing great, Ronnie, ready to dive right in, and we're going to take a look conceptually at how to build an application. Right here in this episode, we're going to see all the little building blocks that go together to put a program together and get it up and operational. And we're going to do it in a easy, approachable manner, right? I don't want to dive right into writing source code right in this episode. So we're going to deal with building blocks, kind of like Legos that we stack together to build an application and get it up and going. If you want to see actual, writing source code and all that, we'll do that in the next episode. But for now, it's really important that we understand some of the basic concepts of development before we start putting it together. And you'll find that once you know those basic concepts, you can write any language. You just need to know the commands at that point. So all the languages share these basic concepts in common, and that's part of the foundations of programming. So that's what we're going to take a look at right here in this episode.
All right, so Don, where are we going to take a look at this beginning in terms of the different concepts that you want to show us?
All right, well, first off, I'm going to use a development environment. When you work with applications or with programming languages, you'll typically have what's called an integrated development environment, or IDE. An IDE is just usually it's just a text editor that you can write your code in, and it'll check for errors, and it'll compile it into a program for you when you're ready to run it. Now, that IDE will vary based on what programming language you pick. The IDE that I'm going to use today is an application called Scratch, and it's managed by MIT, the university, and it's designed to help people learn programming. It's free, so if you want to follow along or do something similar on your own, you are welcome to by just firing up a web browser and going to scratch.mit.edu. Let me bring that URL up on the screen here. So it's scratch, scratch.mit.edu. And when you go there, you can create an account if you want to save things, or you can just hit the create button at the top left, and it'll take you right into this screen right here. And what you'll see is a cat, just a cat sitting in a box, and that's that. Hopefully, is not a litter box. So we got a cat, and we can make the cat do things, right? That's kind of how applications are. The cat is what's called an object. Most programming languages that you work with today are called object-oriented programming languages. And that means that you've got a series of commands, and the commands are all doing something to an object. So for example, in this program, I might move the cat to the right or move the cat to the left. That's me changing that object, doing something to it, right? And I could actually be changing the object itself. Objects have properties, right? This cat is a yellow cat, or maybe orange, I don't know. So it's a color. And if I want to change it to make it a green cat or a blue cat, that's kind of a property of that object, property of that cat. Well, these are terms that we see in programming languages, that you have objects that you work with, that they have properties that you change and tweak. And those properties, in this case, might be things that I'm performing on it, like turning it 15 degrees or pointing it in a direction, 90 degrees off to the right or negative 90 degrees, whatever it is that I want to do to change the way that it's pointing. These are all modifications I can make to that object. And you'll usually have more than one object. Right here, I've just got a cat, but I might stick a background on it. We'll give it a nice, pretty background, right? So now I've got two objects. I've got the cat as my foreground object, and I've got a nice, pretty background here as my second object. And the cat has properties. One set of properties is its location. Notice down here, as I move my cursor around, the X and Y values of my cursor are changing, right? That's it mapping the location that I'm at. And so this cat has a property that's defining where it is on screen. And when you launch a program, one of the first things a program does is it initializes all of its values. It puts them all to a default place. So when my program starts, maybe the cat should start over here on the left side of the screen, right? So that's where it's going to be. That's the initial starting point. And in my program, as I make my list of commands, I can change that. I can tell it to move it somewhere else or turn it upside down or whatever. These are all the list of instructions that we create as we work with a program. Okay. All of these things that I keep describing, they're getting stored and kept track of somewhere here inside of this application. Now, when I write an application, that application is a series of instructions. And the instructions show up over here, and I haven't written any yet. I haven't given any instructions to what I want this cat to do. If I want it to do something very simple, like move from the left to the right side of the screen, I can do that. I just need to think about that. What is it I want the cat to do? I want the program to launch. I want the cat to be on the left side. We've kind of already achieved that, right? I need it to move from left to right. I need to give it an instruction to do that. Well, when I give it an instruction, that instruction needs some additional information. So in Scratch, when you want something to move on screen, it's called gliding, right? This is how we learn a language. Remember how I said the concept is the same, we just need to learn the words? I want to move the cat from the left to the right. I know that's what I want. Well, I need to learn that in Scratch, glide is the word. I want it to glide from the left to the right.
All right, Don, I'm noticing right above glide, there's actually a go-to there. Why not just use that?
All right, so this comes down to language, right? And understanding how that behaves. In English, if I tell Ronnie, I want you to go to that chair over there, what is Ronnie going to do? He's going to move, and I'm going to see him move all the way across the room over there, right? But in a programming language, it's very literal. If I say go to that spot over there, Ronnie would disappear and then reappear over there, right? So my cat, if I wanted this cat to walk from the left to the right, okay, that's what glide does. If I did go to, the cat would disappear and reappear over here. Maybe that's what I want, right? Who knows? If you're making a video game and teleporting is something you've got in the game, then you just want it to reappear. So we have different options. But if I didn't know that language difference, then I might choose the wrong one. And I don't remember from the first time I used it, but I can guarantee you the first time I used it, I probably did do a go to and then saw it reappear and said, whoops, that's not what I want, and then switched to glide. But now, because I've used it enough, I just know, oh, glide is the one that I want to use. We just learned the right word. And that's how programming languages are. So I want it to glide. I'm gonna click on our cat friend here, just make sure I've got it selected. I'm gonna drag that glide and drop it right up here. Now, when I tell it to glide, I have to give it information. And the information is telling it what I want it to do. How long do I want it to glide for? When the cat moves from one side of the screen to the other, how long should that take? I don't know. Is the cat running? Then maybe half a second. Is the cat walking? Maybe 1 second is fine. It's up to me. I pick the time, how long I want it to take that cat to get across the side. That is a variation of this command. The command is glide, and now these are like my custom options that I provide to it. So I'll let it glide for 1 second, all right? And I want it to glide from one part of the screen over here to another part way over here. And so I can use the X, Y values to figure out exactly where I want that cat to go. And so over here, I'm going to tell it that I want it to glide to 133, and I'll do negative 110. All right, so that's where I want it to go. All right, that's going to give it the instructions. Now, when I type these numbers in, where are they going? Right? These numbers are what are being stored in something called a variable. And a variable is probably one of the most important things to learn in programming. All right. Now, unfortunately, it's a little bit hard to demonstrate how variables work right here inside of Scratch. So let's do this. I'm going to use a visual element instead. I've got tucked away here under the desk. If you can't teach something with red Solo cups, then you just can't teach it. So we're going to use some red Solo cups. All right. In a program, I'm going to have a number of different options and values and things that I want to store. And sometimes they stay the same. Those are called constants. If it's a constant, every time I ask for it, it's always going to be the same thing. The speed of light is a constant. If I ask for the speed of light, I'm always going to get the same value back, right? But most of the time we deal with variables. Variables are things that they might stay the same, but they could also change depending on circumstances. So, for example, let's say that I had colors, of which I do. I've got 4 colors, all right? And I asked Ronnie, which one's your favorite color of these 4? I'm limited.
Blue.
Blue. All right, so Ronnie likes blue. I want to remember that Ronnie likes blue. So I'm going to take that and I'm going to stick it away into a variable. And that variable is going to be this red cup. So I'm just going to drop it right in there. Now, the nice part is, in my program, at any time, I can say, oh, I wonder, what was Ronnie's favorite color? And I can go to the bucket and I can pull it out and it's blue. All right. So the cup is the variable and I'm putting a value inside of it, in this case, blue. Now that's nice because if Ronnie changes his mind and Ronnie says, no, you know what, actually, I kind of like green better, then I can take blue out and I can drop green in. And now his favorite color is green. And anytime I ask him, or I need to know, what was Ronnie's favorite color? I go back to the cup, I pull out the value, and it's green, right? That's how variables function. When you write an application, you'll oftentimes have many, many variables. You might have hundreds of variables depending on things. I've got 3 on my screen just from how many seconds I'm going to glide for, the X coordinate, the Y coordinate. There's 3 variables right there, right? And that's where things get a little tricky, because imagine if I didn't just have one variable. Imagine I had multiple. So I ask Ronnie, what's your favorite color? And he says, blue. So I grab blue, I chuck it right in there, right? Well, the computer is storing this in memory, in RAM, right? If I power the computer off, I lose everything in RAM. These go away, so I have to repopulate. But it pops it there into memory, and it sets it in a memory area. Well, your computer has a lot of memory. So here, let me set these out here. And now I have all these different variables. And then I come in and I say, what was Ronnie's favorite color? Uh-oh. Which variable did I store it in? I've got to find the variable. I got to figure out which one. I've got 3 different ones. I don't know, right? So when you create a variable, you're actually doing what's called declaring the variable. Declaring is where we give it a name. We give it an identifier, some way that we'll know to go back and we'll look at it and we can figure it out, right? Declaring a variable is really important. And that's because I'm going to have a lot of these things and I need to be able to use them over and over and over again. Variables are reusable, right? So when I ask him what his favorite color is and he tells me blue, I don't want to just pop that into any random variable with a name that I can't keep track of. So we typically give it a name. So what I'm going to do is I'm going to take a good old Sharpie marker here, and I'm, assuming I can get it open, I'm going to just put a big old R right on this cup so that I can remember that this is the one that's storing Ronnie's favorite color. And I can take blue, I can drop it right in there, and so now I've got Ronnie's favorite color. And then if I want to store my favorite color, I can take another cup, I can just write a giant D on it. We're done. And, there we go. Should have practiced more on that in college. But I'll just write a D on there, and I can say, you know what, my favorite color is green. I'll pop that one in. And so now I've got that. So now when we look at my variables, I'm not having to guess anymore. I can say, what is Ronnie's favorite color? I can go right to the R variable, and I can pull out the blue one. Or I want to know what Don's favorite color is. I can go right to the D one, and I can pull it out, and there it is. And so anytime I need that information, it's right there in those variables. I can get at it, I can pull the information out, and now I know exactly which is which, what data there is. So that's how variables function. Now, Scratch is hiding a little bit of that from us, but I'll show you in a moment where we'll actually define some variables to be able to see them by name. But when we write a program, we have to define that ourselves. And it can get really, really tricky. So for example, let's make this a little more complex. I could have what's called an array. An array is actually a collection of values that are stored together. So maybe I ask Ronnie, I say, Ronnie, what's your favorite color? And he says blue. All right. Well, Ronnie, what's your second favorite color?
Red.
Red. Okay, so I'm going to take that Ronnie variable, and instead of storing just one value in it, the blue, I'm going to store 2, right? I'm going to pop in his favorite color, which is blue, and then I'm going to pop in his second favorite color, red. And now they're stored in one variable, so I add that back to my computer memory, it goes right there. And now when I want to query that, I can say, I want to get Ronnie's favorite color, or I want to get Ronnie's second favorite color. If I want to get one thing specifically out of that variable, normally when you query a variable, you get everything. So I would get red and blue. And then I would look at it and say, well, which one was the favorite, which one was the second? I don't remember. But in an array, the values are stored in order. And so I can say, give me the second one. Open that variable and give me the second value from there. And I can pull it out and I can find, oh, red is the second value, and that's his second favorite, right? So variables can be very, very complex. What we're seeing here on the screen has been simplified. It's kind of hiding those variables. But when we glide, what direction am I gliding? Well, I'm gliding from left to right. So maybe I want to define a variable that says that says, hey, as I move across, I'm going to be moving from left to right. Well, I need to create that variable first. And when you create the variable, you may create it as empty and adjust it as you go, or you may start it with a default value, okay? I'm going to create one. And so when I do that, when I go to create a variable, I'm going to go into my control, and I'm going to hunt down, actually, hang on a second, where is my variable stuck inside of this thing? I'm going to find the set option is what I'm looking for. And we're basically going to set that variable to a default value. Oh, sorry, make a variable. I was in the right spot in the very beginning. So I'm going to create a variable here, and I'm going to call this, we'll just call it direction, okay? And this variable is going to store which direction the cat is moving in. Now notice I've got the option to store it for all sprites or just this one sprite, just the cat. I might have more than one sprite if I have a cat and a dog. Maybe one of them is moving left and one of them is moving right. Or maybe the dog's chasing the cat, so they always move in the same direction. So I've got that choice. How do I want to store this variable? I'll just choose all sprites since I only have one anyway. So I'm going to create that direction variable. And now you'll see where I can set the variable and I can change it. I'm going to start by setting it, and I'm going to set direction to the word none. I've got no direction. Right? In the very beginning, the cat's just standing there. It's got no direction. All right? But then later on, when I start to glide, I'm going to change the direction that I'm moving in. And so there, I can come in and I can say that I want to change direction, and then I can set it to something else. I can say that I want to, or actually, sorry, I didn't do a number, so I can't actually do change like that. So what I need to do instead is do a set direction. So I need to set direction, and I'll change it to right. So I'm going to be moving to the right to these coordinates. Now, if I ever decide to move back to the left, I can do that. If I want to move to the left, I would need to do another glide statement. And so I'm going to come in here and find glide. And this time I'm going to glide for 1 second in the other direction, right? So I did a positive 133 for x before. Now I'm going to do a negative 133. The height will stay at negative 110. That's not going to change. So that the height of the cat stays the same, but it's moving left and right by 133 pixels each time, to the right and back to the left. And I can set that direction. And this time, that direction is going to be left. By setting that variable, I can call the variable and ask questions about it whenever I want and learn about what direction I'm moving in and so on. I start with an empty variable, and then I populate it as I move, and we continue kind of going through. So that's kind of what's going to happen, right? I can take all this and glue it together, and now I've got the start of a program, right? The only thing I really need here is something to trigger the program off. And so if I go under events, I can tell it that when I click the green flag, that's when I want this to start, and it's going to fire off. I might want to have some kind of human interaction. So I might come in and say something like, I want to wait until, not repeat, I want to wait. I'm going to tell it that I want to wait. Maybe I'll immediately set that variable to none, and then I'm going to wait until we press a key. So we'll say, I want to do a key, we'll do space pressed. So I'll have to press the space bar to actually kick things off and get it moving. So that's what I want to do, to be able to get in and see all of that happening. So that's kind of my basic process that I'm going to go through. Now, over here, I see my cat. There it is. I've got my direction. And see how right now the direction is set to 0. The direction has no real value in it. When the application starts, that's going to change. Okay, so I'm going to hit the flag here to start things up. And then the direction changes to none. So it's moving down my list, and I got to that first variable. The variable was set to none. It's waiting for me to press the space bar. And then I'm going to see the variable change to right, and we should glide to the right for 1 second. And then the variable should change to left, and we see it glide to the left for 1 second. And so when I come up here and I hit my flag, or already hit the flag, sorry, I'm going to hit space. There it goes to the right and to the left, right? And all it's really doing is moving down my list of instructions that I've fed into it. And the instructions are pretty simple at this point, right? Nothing really crazy in here. But we can come in and start to do things that are far more complex based on whatever our needs happen to be. So, for example, I was just doing this simple walk here, but maybe I wanted to repeat that. I wanted to repeat it 5 times. Okay, if I wanted to cycle through that 5 times, I need to add in a loop. And so I'm going to go to Control, and I'm going to find the repeat loop. I want to repeat. I want it to walk back and forth 5 times. So when I bring that repeat loop in, I need to tell it where that's going to happen. All right, so it'll be after that space bar. And so now, if we look at that, we set our direction to none and wait for the space bar to be pressed. We press space bar. And then it's going to walk to the right and walk to the left. And then it's going to repeat. And we'll just do it, we'll do it 3 times, so we're not here all day. So we'll repeat 3 times. So it'll walk back and forth a total of 3 times, right? That's a simple loop. And when the loop is done, then we reach the end and we can tell it other things that we want to have happen based on what we need or don't need or whatever, right? So now if I come back here and I'm going to restart the program, and so I restart the program, and you'll see my direction has changed back to none, and I'll press my space bar, and there we go, right and left, and now it's repeating a 2nd time, and now it's repeating a 3rd time, and now the program is done. This logic is what's called the workflow or the flow chart type aspect of an application. I'm just giving it a sequence of events that I want it to do. And you can get really specific on these things. You can do like if statements. If the direction is right, do this. If the direction is left, do that. All sorts of other criteria, right? And you can get really complex really fast. But what you've seen here are actually the basic building blocks of any programming language. You've got variables where you store data. You've got commands where you read the data and perform some kind of action on it. And then you've got logic controls like waiting, pausing, which are basically similar. Waiting, the program is still running and doing stuff. Pausing, it's actually stopped everything until something happens. Then you've got taking an action, right? What those action commands are. You've got additional logic. You might be outputting files. You might be inputting user input. Somebody has to type. Like I had user input here, pressing a space bar, right? All of those are tasks that a program needs to perform. Now, everything I just showed you, I did in Scratch because it's nice and it's visual and it's simple. It's a great way to learn. But you could have done everything I just did in Python, C++, Perl, you name the language. Nothing I did there was groundbreaking. Those are all basic building blocks. You would just have to learn, all right, well, in Scratch they called it glide. What do they call it in this other language that I'm using? And what are the commands that I would issue to achieve the same thing? And once you figure that out, then you can write your program in that language and get it developed. It does take work, takes learning. It's not easy to switch from one language to another, but it's not as hard as learning like a human language. Like if I was to learn Spanish, that would be a nightmare. I could probably learn just about any other computer language before learning a foreign language. Your ears just don't work the same as when you're a kid. But programming languages are pretty easy to pick up because it is just understanding what the right command is for the task you're trying to perform.
All right, Don. Well, thank you for helping us at least to see an example of how we can get some idea of how the programming ends up working for us. But there is more to come in the idea of us going into Python, right? We're going to be picking that up soon.
Absolutely. It's one thing to see a little flowchart like this. That's not really fun. So in the next episode, we're actually going to develop something with Python. So I'll show you how to write a basic Python application, and we'll actually repeat a lot of what we saw here. We'll create some variables. We'll create some commands. We'll output some stuff on the screen. We'll do a loop. So a lot of what we just saw, and actually go a little bit further, we'll do some if statements and so on. So you'll get a chance to see what it's actually like to write an application and get an idea of whether that's something that you're interested in and whether the development is the right career for you.
Yeah, this is a great start and great beginning of us seeing some of the potential that programming has for us. And we do thank you for also watching as well. But signing off for ITProTV, I'm your host, Ronnie Wong.
And I'm Don Pezet.
Stay tuned right here for more of the CompTIA IT Fundamentals show.
Thank you for watching IT Pro TV.